Good morning. So, we start with the second part of the first module, that is introduction module. We will introduce the different types of machine learning. So, there are few broad types of machine learning. There is supervised learning. In supervised learning, what we have is for every, so we said that in learning we use data, and data we can say can comprise of input and the corresponding output. So, for every data instance we can have the input x and the corresponding output y, and from this the machine learning system will build a model so that given an observation x, new observation x, it will try to find out what is the corresponding y. So, this is called supervised learning because for every instance we tell what is the output. So, this is called labeled data. Then we have unsupervised learning. In unsupervised learning, you are only given x. There is no label to the data. And given the data, different data points, you may like to, for example, cluster them or summarize them or find some patterns in them. The third type of machine learning is reinforcement learning. In reinforcement learning, you have an agent who is acting in an environment, and you want to figure out what actions the agent must take at every step, and the action that the agent takes is based on the rewards or penalties that the agent gets in different states. Apart from these three, we have also semi-supervised learning. In semi-supervised learning, it is a combination of supervised and unsupervised learning. That is, you have some labeled training data and you also have a larger amount of unlabeled training data. And you can try to come up with some learning algorithm that can work even when the training data is limited. So, let us look at this picture, which gives us a schematic diagram of supervised learning. In supervised learning, you have a number of training instances. So, this contains the training instances. For the training instances, each instance comprises of input and output. So, this is the first training instance, the second training instance, the third training instance, the nth training instance. Given all these training instances, the learning algorithm will come up with a model, and this model can be used to classify or to find the output or corresponding y value for a new observation x. So, given a new input x, you can use the model to find out the output y. So, this is the schematic of supervised learning. In unsupervised learning, as we discussed, we only have x's. We have different x's, x1, x2, xn. This is the data, and the learning algorithm will produce clusters, will group this data. So, it will be based on the similarity of the data items to each other, we can find out certain groups among the data. So, that is called unsupervised learning. And as I said, we also have semi-supervised learning. In semi-supervised learning, we have a combination of labeled data and unlabeled data. So, this is labeled data. They are data which belong to two different classes. So, one class is circle, the other class is triangle. In semi-supervised learning, apart from having data from the two classes, you also have unlabeled data, which is indicated by the small circles. So, for example, for supervised learning, based on the data, supervised data, you will come up with some function, and if you also have unlabeled data, in addition to the labeled data, you might try to come up with a better function. And we will very briefly talk about reinforcement learning. In fact, we will not cover reinforcement learning in this introductory course on machine learning, but in reinforcement learning, we have an agent which acts in the environment. So, the agent can take action, and this action can impact the environment. Based on, so agent is in a particular state, the agent takes an action, and the environment goes to a new state and gives some reward to the agent. That reward may be a positive reward, can be a negative reward or penalty, or can be nothing at that particular time step. But the agent is continually acting in this world. And the reinforcement learner, what it will do is, it will learn a policy. That is, given a state, what action to take, so that not only the short term reward is optimized, but the overall utility of the agent over its entire time horizon is optimized. So, this is what reinforcement learning is about. We will not talk about details of reinforcement learning in today's class. So, most of the in this course. So, most of this course we will talk about supervised learning, and we will spend some time on unsupervised learning. So, let us look at more details about what supervised learning is about. In supervised learning, you have a set of input features. So, what you have is, you have some features x1, x2, xn. These are the features with respect of which you describe the instances, and you have a target feature y, and you have several instances. Each instance comprises of values of, so suppose this is the instance 1, it comprises of values of this feature x. So, you may have a1, a2, an, and you have instance 2 which is b1, b2, bn, instance 3 which is c1, c2, cn, and the corresponding you have the y values y1, y2, y3, etc. So, your instances are described in terms of features. There are input features and there is the output attribute. And you have a set of training examples. This comprises the training examples, and in each training example, the values for the input features and the target feature are given for each example. Each of this row is one example, and for each example you have the value for instance 3, the value for x1 is c1, the value for x2 is c2, the value for xn is cn, and the value for y is y3. Now, if you are, so this is used for training. During the testing time, you are only given, so you like this, you have many training examples. For test, you are given a test instance. In test instance, you are only given the values of the attributes z1, z2, zn, and you have to output the corresponding y. Now, the y or the target feature can be a discrete valued feature or a continuous valued feature. If y is a discrete valued feature, we call such problem classification problem. So, y can be discrete valued or continuous valued. For example, we can have a discrete valued feature like whether it will rain or not tomorrow, right. So, for such problems are called classification problems. Or we can have a discrete valued feature which, given the symptoms of the patient, predicts whether a patient has a particular disease. Or you have continuous valued feature, then you call such problems regression. Suppose given the values of certain features, you want to predict the price of a house. So, given the location of the house, the floor area of the house, the number of bedrooms and some such features, you want to predict the price of the house, which is a continuous valued or a real valued number, and such problems are called regression problems. Now, so let us look at some examples of classification problem. So, one example is credit scoring. Suppose in this problem we are describing each input in terms of two features, income and savings. So, we have a person, we look at the income and the savings of a person, and we want to predict whether this is a high risk person or a low risk person. And you see in this picture, the high risk persons are labeled with minus and the low risk persons labeled with plus. Now, given this data, you want to come up with a classifier which, given the attributes of a new person, will predict whether that person is high risk or low risk. And this is an example of a rule that you have found. If income is greater than theta 1 and savings is greater than theta 2, then the person is low risk, else the person is high risk. So, this rule you have come up with the rule based on the data. In this case, you can visualize the data and come up with the rule. Now, let us look at an example of a regression problem. You want to find out the price of a used car, and you use certain attributes of the car to predict its price. For example, let us say that you are only looking at the mileage of the car, and based on the mileage you are predicting the price. And these different points, they show they correspond to a particular car, show what is the mileage and what is the corresponding price. So, given the mileage price of several cars, you have the data points and you can come up with a function, so that given a new car, you can, whose mileage is given, you can predict the price. So, in regression you come up with a function which takes as input the input instance and the parameters of the model. Now, we see that in order to describe an instance, features play a very important role. So, observations that you see are analyzed into a set of quantifiable properties which are called features. So, if you want to predict the price of a car or the price of a house, you have to have the right features which will help you to come up with the price. If you want to predict what disease a patient has, you have to come up with the right tests and parameters which will enable you to make that prediction. Now, features are of various types. Features can be categorical. For example, blood group is a feature which has 4 values, A, B, AB and O. Or gender is a feature which has certain values like male, female, etc. Or features can be ordinal like large, medium, small. Features can be integer valued like the number of words in a text, or a feature can be real valued like height. Now, let us look at this table which shows a sample training examples, and for these training examples you have 5 features: action, author, thread, length, where, and the different rows are the different instances. So, instance E1 says action is skips, author is known, thread is new, length is long, and the person is at home. Right? So, these are the different instances. Based on the training examples comprising of these labeled instances, you learn a model so that for a new instance you can predict the output feature. Suppose you have to predict the action of the user. whether the user skips a link or reads a link, and given the value of author, thread, length and where. So, if you come up with a schematic diagram, in supervised learning, you have the training set, the learning algorithm uses the training set to come up with a model or a hypothesis. We will introduce this term in more detail later on. And in the testing phase, given a new instance, you use the hypothesis to predict the value of y. This can also be shown like this. In the training phase, you get the input and the label. From the input, you extract the features of the input and feed it to the machine learning algorithm. Similarly, in the testing phase, given the input, use a feature extractor to extract the features and you feed it to the classifier model to get the label. So, in classification learning, these are the components. You have a task T which has input and output. There is a performance metric P and there is experience E. And the task T comprises of input, which is a set of instances D1, D2, Dn. Each instance has a set of features. We can represent an instance as a vector D equal to x1, x2, xn, and you have to output a set of predictions for the inputs. Now, what we will do is that we will look at some sample classification tasks. Let us say the task is medical diagnosis. The instance are patient record comprising of the features of blood pressure, diastolic and systolic, age of the patient, the sex of the patient, the BMI of the patient, cholesterol of the patient. And the labels are whether the person is low risk of heart disease or high risk of heart disease. There are two classes. We call them positive class and negative class. One is the positive class, the other is a negative class. And then there are some other examples. Finding company names in text. So, given a particular name, you want to find out, is it a, given a particular word, you want to find out, is it the name of a company. This is the entity recognition task in text mining. So, the instance is a word and the context of the word. What words, which words come before the word, which words come after the word, and maybe certain features of the word. For example, is the word capitalized? Is the word following this word INC? Is the bigram or two words previous this word contains acquired by, and so on. And the output labels are first, later, outside. That is, if it is a company name, is it the first name of first word in that name? Is it inside a company name? Is it outside a company name? For example, in a running text, you may have Microsoft Corporation. Acquired XYZ, right? So, let us say Microsoft Corporation together is the name of a company, and this is the first word in the name. This is a later word in the name, and let us say XYZ is also a company name, and this is also the first word in the name, and the word acquired is not a company name, so it is outside. So, we may use this sort of convention in order to label company names in text, and we can have a machine learning algorithm finding these labels. Similarly, let us look at the fourth row, which is image recognition. The input are image, which is 1920 by 1080 pixels, and each pixel has a color, and your output is whether the image is the image of a house or not. So, the performance metric in classification learning can be what is the probability of wrong prediction, what is the probability, or it can be the performance metric can be the accuracy or the probability of wrong prediction or the error on examples from the distribution from which the instances are drawn. Right? So, in classification learning, the task comprises, as we said, a set of input instances d1, d2, dn, and the output is a set of predictions y1, y2, yn. The performance metric is what is the probability of wrong prediction, and the experience is a set of labeled examples where y are the true labels for x. For those training examples, you have the ground truth data. And these examples come from some distribution, some fixed distribution. During the training, these examples are drawn from a distribution, and what is expected when we get test instances, those examples also come from the same distribution. Now, how do you get data for the learning problem? For example, in medical diagnosis problem which we have seen, in order to get data, when you have a patient, you find out the different parameters of the patient, and you have to wait for the next several years to find out did the patient get heart disease or not. So, you have to wait to look for the heart disease. Finding company names in text, how do you get the data? You get some text and you get them manually annotated for company names. This forms the training set. For image recognition, the data is a set of images for which some humans or some people have labeled those images. So, this is how you get data. And as we said that when we want to look at the representation of the function, there are two things. One is the features, the other is the function class. And we will talk about this in greater detail later. The function class can be a linear function in terms of the attributes. The function can be a decision tree, which we will talk about in week 2. It can be a linear function, it can be a decision tree, or it can be other functions like multivariate linear function as shown in the picture, or single layer perceptron, which is a unit of a neural network, which we will talk about later in this class. Or it can be multi-layer neural network, which we will also cover later. And given the type of function, the hypothesis space is the set of candidate outputs that you can get, candidate functions that you get. So, supervised learning, you can think of, there is a set of functions which comprise the hypothesis space, and you want to find out that function from the hypothesis space which is most probable given your training example. Again, we will talk about this in detail later. So, that if we just look at the basic terminology, we have some features which are distinct traits or attributes that are used to describe each instance, and this set of features, they comprise the feature vector. The instance space is a set of possible objects that you can describe by the feature, and each example has the value of the input and the value of the output. A concept, suppose you are trying to find out, is this the object, this object an image of a face? So, the concept is a subset of objects in the instance space. Among all possible images, some images, a subset of the images are images of face. The target function is the function that you are trying to learn. It will map each instance to its label. That is it a face or is it not a face? We have already talked about what is example and what is training data. So, with this, we end today's module, and we will start with the next module in the next class. Thank you very much.